Starting now.
So
Okay.
this is your home page, right?
Uh-huh.
All these are alarms,
Mhm.
right? If you see one of these blinking on red, like you see up here, you know that you are something's happening, right?
Mhm.
This one is blinking up. I gotta fix it. Don't put mine on that. If they turn red and gonna go alarm, it's telling you right there. AC unit 2-5 leak detector. Now it's normal. If there were a leak, it will turn into an alarm. It will blink, right? Same thing with all of them. All these are leak detectors, just like the device. And then if there's water between the two prongs, it will close a contact and it will generate an alarm, right? As long nothing is red in here, you're good. If tomorrow something is red, you're gonna refer to the what it says here, AC unit 2-5. Oh, I need 2-5. I know where it is. You go, right? Okay. In here, this is you could see it. ppm, particle per million, right?
Yeah.
So this is GFX, general exhaust. 9M, that's the mezzanine. CO2, it's measuring CO2, right? This thing has to be between the 800 and the 1200. You see right there?
Right.
That's your range. You're good. Right now you are in what, 700 something, right?
Yeah.
If it passed 1200,
It's a
it
problem.
means that
Too much
you,
CO2.
right, something is not working. An exhaust fan or something is not taking air out or no fresh air in, right? Either one. It could be the exhaust fan is not taking the air out, or it could be the fresh air fan not bringing air in, right? So those are things that once you understand them, you know where to go, right? It's either or, the exhaust fan or the fresh air fan. So right here you have another one. It's the same thing. Particle per minute per million, 759. You good. You are even less of wherever. Right? Okay. Right here is your boiler. Hot water supply. Right now the boilers are supplying 144 degrees. You good, right? Between 100 is the minimum and your max is 180. If something happened, probably you will have
Later,
an
puteros.
alarm or trip somewhere. This is your hot water DP, right?
What does DP mean?
Differential pressure.
Oh.
It's not double penetration. So this is how you control the BFD speed, right? You set up the this is all mechanical, right? The engineer will tell you, right? Oh, we want to keep whatever. In this case, it seems like it's 12 psi, I would say, or maybe 15. It's a little far. I don't know, but they're gonna give you a setting, right? The guy that designed the system, the engineer that designed the system, it will give us at the control company a set point.
Okay.
He's gonna say, I want 12 psi across my lines, right? So that's what it is. It's a sensor with a hose or a little pipe on one side, on the supply side, and another hose on the return side.
Where?
And then
On-
in between them, you're gonna have a sensor measuring the difference. So if the difference drop, it will increase the speed. You coming tomorrow? See you Monday then?
Monday.
Okay. I will
That's
have a
it.
good weekend.
Thank you.
So if the pressure drops or increase, it will affect the pump's speed, right? So you need more pressure because someone start open up water or losing water for whatever reason. The pump will ramp up and it will increase the pressure until reach the.
So these
the
are
set-
installed at the pumps, right?
These are installed on the pipes.
On the pipes.
On the pipes.
What pipes? Where?
This one is hot water.
Oh, hot water.
HD,
Okay. Okay.
hot water
okay.
DP.
Okay. So these
Okay.
are all boiler stuff, right?
This is boiler, yes.
Okay. I see.
Right here, you
That's
see
a
chill
chill
water
water.
supply. This is what you're seeing out of the chillers. Chill water supply is on a 55.8 degrees. Chill water differential pressure. It seems like in this case they want 5, no, maybe more. I don't know what it is. Usually it's 5, 7. I don't know. That's all
Between
engineering.
5 and 25.
Right.
That's
Yeah,
what you want.
right. So same thing like this one. It's a DP. I show you a DP one on my way out. And then condenser water supply. You know that, right, from the chillers. It's the same thing. And condenser water DP. Same thing. Exactly same thing. This is how much pressure difference is between the water that goes into the device than the water that comes out of the device. Got it?
Got it.
Okay. Now let's go chill plant, right? Right now the chiller plant is off, but this is what we were talking about, right? You have your return temperature. You have to be careful with this because people say return to the unit or returns to the tower, right? You need to understand how the system been built and the terminology that they're using, right? Because like I say, sometimes they say, oh, the return water, return to where? Return to the building or return to the tower, right? Because remember that this water comes from the cooling tower, right? This water on the brown side, on the brown pipe, is water coming from the cooling tower, right? All this brown in here is water coming from the cooling tower.
So this is returning to the building. This
Right,
specific one.
return to the building,
Right.
supply to the cooling tower, or supply to the build. No, this seems to be supply to the building,
Okay.
return to the
Return
cooling
to the-
tower.
Okay.
Right, and then the light blue is the chill water, right? It's the water that these are huge compressors. That's what they are, right? Just on oversized. They cold the water, so the compressor could work up to like 80-degree water, and it will chill the water, and you get colder water.
Where does the 80 come from? This is standard or set?
standard.
Okay.
Standard.
Okay.
Yeah, no, I'm telling you, so you know that compressor could work up to 80 degrees water,
Okay.
right? So the
To-
water is
to-
above that, the compressor probably won't really cool down that much.
Okay.
You need to cool the compressor in order to chill this guy. It's a compressor, right? So the guy's like,
Yeah, so it's running, right.
it generates heat, right? Because it's a motion. A motion will generate heat. So you need to keep that temperature low so the compressor can keep working like a car,
Right,
You need to cool down the engine
Right.
with the what's called it, the engine, how you call the
With the
radiator.
oil? Oh,
With the radiator.
So so in this case, you're talking about the water we're supplying to the compressor needs to be cold so
No.
it can cool the
No.
compressor down. Oh.
Yes, right.
Yeah.
So the water that you supply to the chiller, it could be up to 80 degrees.
I see. Not more. So,
No more.
but
Right.
anything
But
more
this
is
one-
raising the temperature higher.
It won't cool. It won't cool. It won't cool the
right.
compressor.
Right.
Right.
I see.
Right. This, remember, you have condenser water, which is the brown, and you have chilled water, which is the blue. Right? The condenser water comes from the tower. The chilled water comes out of the compressor, out of the chillers. So this water, the blue water, is the water that goes into the unit and cools the spaces. Right? If you have an air-handled unit, this is how you cool the space with this water. Okay. Then you have your pumps, right? One set of pumps for the cooling tower water, one set of pumps for your chilled water, right? Now you have this thing in here, which is called free cooling, right? That's during this time when you're like between seasons, right? Sometimes the cooling tower cools the water cold enough that you could cool your building with the water without using the compressors. You see the compressors now are off. You don't need them because the cooling tower water is cold enough to cool the building. So what you do is using this piece of device, which is called a heat exchanger. That's what it is, the HX, heat exchanger, right? And it's the same logic, right? The water from the cooling tower will come, will get into it, actually come from the bottom, right? It comes from the bottom, it goes inside, and go back to the cooling tower. And this is the water that you're running through the building, right? There's almost no exchange. You see 57, 58, because the cooling tower water is good enough. So this is only on like in between seasons. You're not gonna see this running or open. You see the valves are open during summer because you need the water to be even colder.